Hello everyone, my name is Pawan Shetty. I'm part of the hardware engineering team within Facebook. Today, along with my colleague Soumya, we will go through a brief overview of the hardware platform designed specifically for inference at Facebook. In the last OCP, we presented multiple module form factors that we defined for accelerator use cases. In this presentation, we will go a little more deeper into the actual system hardware that's being designed for inference use cases. While designing a platform specifically for inference, there are a few key requirements that come into play. First and foremost, we need to increase the network bandwidth. Given that accelerators are able to process data at a much faster rate than what we could with servers today, we need to match the input data rate as well to actually realize this performance. Larger models translate to bigger embedding tables and higher memory bandwidth requirements. This also goes back to the network interface card to the server. We need to upgrade the bandwidth capability on the NIC. Given that this is a new platform, we try to avoid reinventing the wheel and try to leverage the existing single socket platform as much as possible. This helps us deploy the system faster and easily integrate it into our existing infrastructure. Having a modular design gives us a lot of flexibility to change system configurations during the development as you find different bottlenecks or different performance optimizations. Given that we are trying to design accelerators into an existing platform, there are some unique power density and thermal challenges that come up, and the platform design needs to consider that. The existing Yosemite V2 platform houses 4 single socket servers today with up to 25 gig support on the NIC for each host. On the YV2.50 platform, we replaced 2 of these servers with carrier cards, which house the accelerators. On the host side, we increased the NIC bandwidth to 50 gig per host by rerouting the PCIe on the baseboard. So each host has a by 8 link going to a 100 gig multi-host NIC. In this platform, we also increased the power capability by modifying the input cables at the 12-volt connector. And we increased the cooling capability by switching to a 15K fan. These are some more details on the variations from YV2. The mechanical design and BMC implementation remains exactly the same. However, there are changes on PCI routing and the power capability. A little more details on the carrier card itself. We use the Glacier Point V2 carrier card, which is designed for multiple accelerator applications, not just inference. This carrier card supports M.2 or dual M.2 modules, which are connected to a PCI switch through a by 4 or a by 8 link. The PCI switch in turn connects to the server through a by 16 uplink. The card supports up to 180 watt power, which goes to these accelerator modules. This card also has a microcontroller to support the out-of-band signaling to the accelerators like I2C, JTAG, or UART. It also helps in sensor control and general board health management. This microcontroller is called the Bridge IC, and it abstracts the carrier card functions to the BMC, which is shared between the servers in the sled. For the accelerator module, we define 2 form factors. The M.2 module here is heavily leveraged from the existing storage NVMe flash SSD. This can support up to 14 watt power and a by 4 PCI interface, which can either be Gen 3 or Gen 4. This is a very familiar form factor, which gives us the advantage that we can plug it into multiple server types in our fleet. This also opens up possibilities of having a mixture of storage devices and accelerators across a single PCIe switch. This particular module size and power budget allows us to be very flexible on the system configuration and modify number of modules in the system as we go about the development. However, the M.2 module form factor doesn't work for many other ASICs or many other applications we are targeting. So we defined a larger module called the dual M.2 form factor, which has two M.2 connectors side by side. This enables us to support higher power ASICs, which need more real estate, as well as more memory on the card. This module is backward compatible to the M.2 card, which means that the same platform can be used to support both modules, both from a mechanical or electrical perspective. For more details on the modularity of the design, I now turn over the presentation to Soumya. Thank you.
Continuing the presentation of Accelerator platform, I'm going to be, in the next few slides, I'm going to be talking about the modular design aspects in this platform and also review the design and challenges we faced and looking forward, what are the improvements we're looking forward to in the next gen platform. When designing a system, we always consider whether modular design or a homogeneous system. Think about the challenges debugging these systems when they're deployed in large volumes to the data center. The answer is obvious. Modular design has its advantages, and it's a great sustainability solution. Especially when it comes to monitoring or debugging, it is much easier to gather data or root cause an issue with modular design. Even replacing the failed units on site is much simpler. You can refer to presentations by one of my colleagues on server level module design for more information if you're interested. But here we are focusing on specifically M.2 modules for this Inference Accelerator platform. One of the reasons to go with modular design is that it prevents blast radius. Module interface here is PCIe. This combination works to our advantage. For example, easier to contain errors through PCI DPC feature to a particular module or range of modules, and thus preventing any system recovery mechanism to kick in. With the modular design, when required, it is easier to disable or power down with the modules and still continue processing inference workloads. If the workload is larger, Glow compiler supports partitioning of models across different modules. With M.2 modules, we can enable peer-to-peer communication between the devices, which improves latency by avoiding the usage of main memory as a temporary storage. It is a standardized design. Single platform for different accelerator use cases. For example, you could use the same chassis for video or inference modules. Standardized design for server management for different use cases. It makes it easier in terms of standardizing the gathering of ASIC telemetry. You can leverage OpenBMC, which is common for monitoring. Chassis management in DC will not be based on the use case. It is easier to enable more vendors as well. Same thing for platform validation. This advantage of shared validation plans. It is easy sustaining across multiple vendors. And after, in this piece, reviewing the design, we did encounter some challenges during the evaluation of design of this platform. There is room for growth in terms of optimizing latency and throughput. Bandwidth to module can also affect performance, an area for improvement. With larger neural network inference models, potentially NIC could still be the bottleneck or gating factor. That being said, here's a list of enhancements we can look forward to in the next-gen platform. Current design is based off PCIe Gen 3. We can take advantage of Gen 4 PCI interface in the next-gen platform. Anticipating higher NIC, looking into having standalone NIC for each server as opposed to shared NIC. This reduces shared NIC failure domains. So based on the listed in the previous slides, here are some of the enhancements we can look forward to in our next-gen platform. Sharing here is the product image, which shows the whole sled, GPV2, interface for modules, and Twin Lake. Let us know if you have any questions. We are sharing here our email addresses. Feel free to reach out to us. Also sharing some of the specification documents here, which should be accessible. Feel free to reach us out with questions. Thank you.
Two, one.
Hi, everyone. I think one of the questions was on the module vendors. In today's presentation, we want to focus on the platform alone, but we do have a blog post on Kings Canyon platform for Facebook, where we have listed some of the module vendors that we have been working on with for this particular platform.